Hello, it's time again for our SHS2 Mathematics program, made possible by the Center for National Distance Learning and Open Schooling, CENDLOS. This is our second on modular arithmetic. Today's topic is addition and multiplication in modular arithmetic. Today, we hope that by the time I say goodbye, you should be able to carry out the operations of addition and multiplication in modular arithmetic. Now, what can you recall from our last lesson? Let's see. We touched on linear variables using the number line, cyclic variables using the circle, and then we also learned how to write a number in a given modulo. In today's lesson, as I stated earlier, we are going to discuss addition and multiplication in modular arithmetic. Okay, let's start with addition. We have two methods of doing addition in modular arithmetic. So we are going to take the first one, and then later we'll look at the second. Now, in the first method, to find the sum of a given integer in a particular modular system, we first add the integers, and then secondly, we find the remainder when the sum is divided by the given modulo. We'll take 5 examples to make the points very clear to you. So find the sum of the following numbers in the given moduli. Example A, 17 plus 25 mod 6. Now what we do is we add the two numbers to get an answer of 42, and then we change 42 to a smaller number in mod 6. So to change the 42, we will divide the 42 by 6. That gives us a remainder of 0. Therefore, 17 plus 25 mod 6 is equal to 0 mod 6. Example B. We want to find the sum of 15 and 13 in mod 11. So once again, we add the two numbers. That gives us 28 mod 11. So we divide 28 by 11. We have 2 remainder 6. And therefore, we say 15 plus 13 mod 11 is equal to 6 mod 11. Example C. We want to find the sum of 17 and 25 and 10 in mod 7. I hope you know what sum is. That means we want to find 17 plus 25 plus 10 in mod 7. So again, we add the 3 numbers to get 52. And then we divide 52 by 7. And that gives us 7 remainder 3. Therefore, we say 17 plus 25 plus 10 mod 7 is equal to 3 mod 7. Example D. We are finding 14 plus 8 mod 9. So what do? We divide 22 by 9. You know how many times 9 can go into 22? Twice. And then we have a remainder of 4. And therefore we say 14 plus 8 mod 9 is equal to 4 mod 9. That is quite easy, isn't it? Let's look at one more example. We have 65 plus 49 in mod 8. So again, we add the two numbers and we get 114 mod 8. We have to change the 114 to a smaller number in mod 8. So we are going to divide. Now dividing 114 by 8 we have 14 remainder 2. That means that 8 will go into 114 14 times, and we have a remainder of 2. And therefore, 65 plus 49 in mode 8 is equal to 2 mode 8. I believe this is clear, isn't it? Now take note. The rule is add first, then write your answer in the required modulo. Now we want to look at the second method of doing addition in modular arithmetic. Now by this second method, what we do is we reduce the given integers separately to the given modulo. And then secondly, we add the results. And finally, we convert again, when necessary, to a smaller number in the mode. So we are going to quickly take the same exercise we did and use the second method to work them. So example A, we are working 17 plus 25 in mode 6. We will change the 17 to mode 6 by dividing and taking the remainder. That gives us 5. Then we will change 25 also to mode 6 by dividing and taking the remainder. The remainder there will be 1. And so our question becomes 5 plus 1 mode 6. That gives us 6 mode 6. But remember, in mode 6, we can't leave the 6 as 6. So we'll have to divide, and we get a remainder of 0. So finally, our answer is 0 mode 6. Therefore, we say 17 plus 25 mode 6 is equal to 0 mode 6. Now, this seems like a slightly longer method, but invariably, it is much, much easier for you to work. Let's look at the second example. We have 15 plus 13 mode 11. So we change 15 to a smaller number, and change 13 to a smaller number. We get 4 plus 2 mode 11. Now we add the 4 plus 2 to get 6 in mode 11. Now 6 is already in the simplest form it can be, so our answer is just 6 mode 11. And therefore 15 plus 13 in mode 11 is equal to 6 mode 11. So example C. We have 17 plus 25 plus 10 in mode 7. We will change each of these numbers separately. So changing 17 gives us a remainder of 3. Changing 25 gives us a remainder of 4. I'm sure you know what we are doing. We are dividing 25 by 7. That gives us 3 remainder 4. So we write down the 4. Then we change 10 to mode 7. We divide 10 by 7 and we get a remainder of 3. So we change the original question to 3 plus 4 plus 3 in mode 7. And that gives us 10 mode 7. The 10 we can reduce further. So we divide again by 7 and we get 1 remainder 3. And therefore, 17 plus 25 plus 10 mode 7 becomes 3 mode 7. Example D. We have 14 plus 8 mode 9. Change each of these numbers separately. 14 reduced gives us 5. But 8 is already in the simplest form, and so we leave it like that. We add 8 and 5 and we get 13 mod 9. Now we can reduce 13 further. So we divide again by 9 and we get 1 remainder 4. And so our final answer is 4 mod 9. And therefore 14 plus 8 mod 9 is equal to 4 mod 9. Example E. We have 65 plus 49 in mode 8. Reduce each number separately. Add the two answers. So 65 mode 8 when reduced gives us 1. 49 mode 8 when reduced gives us 1. So the question becomes 1 plus 1 mode 8. And we get 2 mode 8. Therefore, 65 plus 49 mod 8 is equal to 2 mod 8. Alright, that's quite easy. Now, let's continue with multiplication and see how it goes. Again, multiplication in modular arithmetic can be done in two ways. The first is similar to the first method we used for addition, and the second is similar to the second method for addition. So let's take the first method. To find the product of given integers in a particular modular system, and by product we mean multiply, we will first multiply the two integers and then we find the remainder when the answer is divided by the given modulo. Now let's try this method. So find the product of these integers in the given moduli. Example A is 13 times 11 mod 7. We will multiply the two numbers. You can use your calculator if you are not sure of your multiplication. And that gives us 143 mod 7. So what do? We change 143 to a smaller number in mod 7. Now dividing 143 by 7, we get 20 remainder 3. Therefore, 13 times 11 mod 7 is equal to 3 mod 7. Let's look at the second example. We have 123 times 3 in mod 6. First thing, multiply the two numbers. That gives us 369 mod 6. So we now change the 369 by dividing by 6 and keeping the remainder. So dividing 369 by 6, we get 61 remainder 3. And therefore, 123 times 3 mod 6 is equal to 3 mod 6. Example 3. 18 times 6 times 5 mod 15. The first thing, multiply the three numbers. Our answer is 540 mod 15. Next thing, change 540 to a smaller number in mod 15. We do that by dividing 540 by 15 and keeping the remainder. When we divide, we get 36 remainder 0. And therefore, 18 times 6 times 5 mod 15 is simply equal to 0 mod 15. D. We have 64 times 13 in mod 11. So again, we will multiply the two numbers, and that gives us 832 mod 11. We have to change the 832 to a smaller number, mod 11. So again, we divide. Dividing, we get 75, remainder 7. And so 64 times 13 in mod 11 is equal to 7 mod 11. Let's look at the fifth example, and by then I'm sure you will get this perfectly. So this time we have 14 times 23 in mod 13. I'm sure you can remember the steps. Multiply the two numbers. That gives us 322 in mod 13. What do we do next? We divide 322 by 13. Dividing, we get 24, remainder 10. And therefore, 14 times 23 in mod 13 is equal to 10 mod 13. Now we have 94 times 12 times 65 in mod 9. That will give us a big answer. But once you have a calculator, that can be simply worked out. Now multiplying, we get 73,320 mod 9. So we have to divide 73,320 by 9. Now to do that, you can use the long division. You take the first two numbers, 73, divide by 9, and you get 8. 8 times 9 is 72. You have a remainder of 1. You bring down the next number, 3. That gives us 13. 13 divided by 9 gives us 1. Because 1 times 9 is 9. Remainder 4. And so we take the 4 to the next number and we get 42. We divide 42 by 9 and we get 4. Because 4 times 9 is 36. If you subtract 36 from 42, you get a remainder 8. Then we add the other last number, which is 0. So we have 80. Now 80 divided by 9 will give us a remainder of 6. And that is how we are getting our answers. So finally, we have 94 times 12 times 65 mod 9 to give us 6 mod 9. Now, just as we did for addition, we can use the second method for multiplication as well. I hope you remember the second method for addition. So in this case, to find the product or the multiplication of two integers in any particular mode, we first will reduce each of the numbers separately to the given mode. We multiply the results, and then we finally reduce the answer to the given mode. Again, we are going to take the same exercise that we did before and use this second method so you can see how it works. Now in A, we have 13 times 11 mod 7. So you change the 13 to mod 7 and change 11 to mod 7. Now 13, when you divide, will give you a remainder of 6. When you divide 11 by 7, you get a remainder of 4. So the question becomes 6 times 4 mod 7. And 6 times 4 is 24. So we get 24 mod 7, and we have to reduce again. So we divide 24 by 7, and we get 3, remainder 3. Therefore, we say 13 times 11 mod 7 is equal to 3 mod 7. Now B. The question is 123 times 3 mod 6. We will change the first number, 123, to mod 6. And then we multiply by 3. That is because 3 is already in the simplest form in mod 6. So multiplying, we get 9 mod 6. We have to divide the 9 by 6. That gives us 1 remainder 3. And so we say 123 times 3 mod 6 is equal to 3 mod 6. C. We have 18 times 6 times 5 mod 15. What do? Reduce each number separately. We reduce the 18 to mod 15 and we get a remainder of 3. Now the 6, as you can see, is already in the simplest form. The 5 is already in the simplest form. And so we just multiply the 3 numbers. So we have 3 times 6 times 5 mod 15. And that gives us 90 mod 15. And then we have to reduce our 90. We divide 90 by 15 to get 6 remainder 0. Therefore, 18 times 6 times 5 in mod 15 is equal to 0 mod 15. Now D, we have 64 times 13 in mod 11. Remember, change each number separately. So we are changing 64 to mod 11. That gives us a remainder of 9. We change 13 to mod 11 and it gives us a remainder of 2. Then we multiply 9 by 2 and we get 18, which we will change again to mod 11. So changing 18 to mod 11 gives us 1 remainder 7. And so our answer is 7 mod 11. Now E. The question is 14 times 23 mod 13. We will change each number separately. Changing the first number 14 gives us remainder of 1. Changing the second number 23 gives us a remainder of 10. 1 times 10 is 10 mod 13. As you can see, 10 is already smaller than our mod, so we will not need to change. And therefore, we say 14 times 23 mod 13 is equal to 10 mod 13. I'm sure you are beginning to see that this method makes the work easier. Now let's look at F. Question F says 94 times 12 times 65 mod 9. Remember, change each number separately. So changing, we have 4 times 3 times 2 mod 9. When we multiply these 3 numbers, we get 24 mod 9. So we have to change the 24 to a smaller number in mod 9. That gives us a remainder of 6. And therefore, 94 times 12 times 65 mod 9 is simply equal to 6 mod 9. Interesting, right? Do you notice that any time the required modulo is a factor of the integer, the resultant modulo is 0? That is because when a number is a complete multiple of the modulo, there is no remainder. Keep that also in your tip bag. I hope that by now you are clear in your mind how to choose which procedure is best for you. And in this lesson, we learned 2 methods. 2 methods for addition two methods for multiplication. We said that to find the sum, you first add the two integers and find the remainder when the sum is divided by the given modulo. Or you reduce the given integers separately to a smaller number. Then add the results and convert your answer to the required modulo. Again, to find the product or to multiply any given integers in a particular modular system, you first multiply the integers, find the remainder when the product is divided by the given modulo. Or you use the second method where we reduce the integers separately to the given modulo, multiply the answers, and finally convert your final answer to the required modulo. Well, we have come to the end of today's lesson. I'm sure you found this lesson very easy to understand. Keep practicing. Join us again for the next lesson, where we will learn about negative numbers in the modular arithmetic. Goodbye.